Hi guys, today's new topic is about second law of thermodynamics. It's about efficiency. Efficiency measures how well an engine works or an engine operates. Now, this is the equation that we're going to be using. Efficiency will be equal to the net work of the system divided by the heat added in the system. These other two equations are derived from the main equation. So, which one are you going to use? That will depend on your givens. Now, I want you to know that this efficiency will always be less than 1. Because 1 represents 100%, but real engines, are not 100% efficient. So the idea of this is that we're going to know how efficient an engine is. Imagine that we are in our house and we buy water. Now, after a certain time of water, and imagine that we are in summer here, or that this container has a leak. After this amount of time, the initial 5 gallons will turn in 4.5 gallons. Why is that? That is because the efficiency cannot be 100%. Now, in this case, there were so many factors that altered the initial amount of water, okay? Those factors are known as time, temperature, and other examples are leaks. Now, if I need to calculate the efficiency of this system, will be final divided by initial. So if I use the simple equation of a percentage, I will have 4.5 divided by 5. As we did over here, I could say that this system that I have over here is 0.9, or if I multiply times 100, I will have 90% efficiency. So basically, this is what we're going to do in the second law of thermodynamics. It's actually a very simple topic. Now, let's see the first example. This sample problem is in page, let me see the page 350. Now, the efficiency of a gasoline engine that during one cycle receives 204 joules of energy from what? From combustion, and loses 153 joules as heat to the exhaust. Now, from this problem, the first step that we're going to do is write the givens. Now, what do we need in order to write the givens? We need our equation. There we go. So, from this problem, I want to know what are my givens. So, first of all, it says find the efficiency. So, efficiency is going to be unknown. This is what I care the most. Now, after that, the problem is giving me energy received. From all these equations here, energy received, which one do you think is? Energy received could be the efficiency, the work net, or the heat added to the system. Could be the heat added to the system, the heat removed from the system. So which one do you think it is? So, energy received will be the Q added to the system. So Q added is 204 joules. And now the one that says and loses to the exhaust 153 joules is going to be the Q removed, is the energy or the heat that is being thrown or given by the system. Okay, so this is going to be Q removed, it's going to be 153 joules. So according to our givens, which equation is going to be the most useful to use? The first one, I don't have my work, so I cannot use it. The second one, I could use the second one, yes, because I have my Q added and my Q removed. So I can use 1 or 2 because here I have Q removed and Q add. So which one are you going to use? It's up to you. The answer won't vary. Now, let's solve the problem. Solution. Efficiency. We write the equation for efficiency is equal to, I will use the one in the middle, Q added minus Q removed divided by Q or heat added to the system. Now let's plug in the values that we have. The Q added was 204 joules minus from the problem for the formula. The Q removed was 153 joules, and the heat or the energy added to the system was 204. We use our calculator, the one that we never forget at home, because basically you are in your house right now. And remember, we solve the top of the problem first and then we divide. So this is equal to 0.25. The efficiency of that engine is 0.25. Or we can say that this engine is 25% efficient. This is the first problem. Now let's do another one. Sorry because of the mess. A steam engine takes 198 times 10 to the third power joules and exhausts 149 times 10 to the third power joules as heat per cycle. What is its efficiency? Now again, the wise first step is take out the givens, and for knowing the givens or to identify the givens, we need to be aware of the formula that we are going to use. Now, what are the givens for this problem? Okay, it says a steam engine takes in, sorry, I kind of missed it, takes in 198 times 10 to the third power joules. When you read takes in, we're going to know that this is added. Okay? Imagine like this engine is digging in fuel. Okay? Now, well, not fuel because it's steam, so it's digging in steam. No, what is in is going to be added, and what is out, exhaust for example, is going to be removed. So what is in is going to be Q added equals 198 times 10 to the third power joules. What is removed, or what is exhaust, or what is takes out, is going to be the Q removed. Now, this is 149 times 10 to the third power joules. Now, what do we need to find? Its efficiency. So this is the unknown. Again, which one can we use? 1, 2, or 3? No work is given in the problem, so we're going to use 1 or 2. In the exercise before, I already used the formula in the middle, so right now we'll use the third one, only for you to see that you can use both of them. So first we write the equation and we say 1 minus Q removed divided by Q added. Now just let's plug in the values, and you're gonna have 1 minus Q removed, that is 149 times 10 to the third power joules, divided by the Q, or the heat added to the system, which is 198 times 10 to the third power joules. So this is going to be, in my calculator, I will solve the division first, and then I will subtract from 1. So 149 times 10 to the third power divided by 198 times 10 to the third power. Sorry for the sound, I didn't expect this to happen. So I have this answer, so I will subtract from 1, and this is equal to 0.247. So the efficiency of this steam engine is, if I multiply times 100, 24.75% efficient. As you can see, the problems are very easy to solve. You just need to identify the givens. Now I'm going to develop another example right here. A turbine takes in 67,500 joules as heat and does 18,100 joules of work during each cycle. Now calculate its efficiency. Again, it's asking us to find efficiency. So first of all, we need to write the givens. It is asking us efficiency. But now, let's read. Let's take out the rest of the givens. It says a turbine takes in, as we're talking about takes in, remember, takes in, dig in. So what is in is added. So we have Q added to the system equals 67,500 joules. And those 18,100 joules of work during each cycle. So this is a different given. As you can see, here we have work. Work equals 18,100 joules. Now from this given, which one I have to use? Obviously, I will be using the equation that involves work. So first step is, in the solution, write the equation that we're going to use, W net divided by Q added to the system. Now let's plug in the values, and we're gonna have 18,100 joules divided by and then of course we don't forget to use the calculator. So now we can conclude that the efficiency of the turbine is 0.268, or if you want to write it as a percentage, just multiply times 100, or 26.81% efficient. So as you can see, these problems are very easy to solve. I hope you guys understand. See you.